Here is the function. We are going to examine the limit of the function f of x equals 3x as x approaches 2. Understanding the concept of a limit. A limit describes the behavior of a function as the input gets close to a particular value. If x approaches c, from the left and from the right, the function's value gets arbitrarily close to a single value L, then the limit of f of x is L. Visual understanding through a graph approaches 2 from the left. This is called the left-hand limit and is written as x approaches 2 from the right. This is called the right-hand limit and is written as, since the left-hand limit and the right-hand limit are equal, we can conclude that the limit of f of x as x approaches 2 is 6. Philosophical perspective. The concept of a limit focuses on how a function gets closer to a certain value rather than actually reaching that value. For the function 3x, it never actually reaches 6 before x equals 2, but as x gets infinitely close to 2, the function value gets infinitely close to 6. The limit of the following function as x approaches 1. Let's draw the graph. Since the denominator becomes 0 when x equals 1 is not included in the domain. As x approaches 1 from the left, the function value gets closer to 3. As x approaches 1 from the right, the function value also gets closer to 3. Therefore, we can conclude that the limit of the function as x approaches 1 is 3. Let's numerically verify the limit of the following function as x approaches 1. We will create a table. As x gets closer to 1 with values 0.75, 0.9, 0.99, and 0.999, the function value of f of x gets closer to 3 with values 2.313, 2.710, 2.970, and 2.997. As x gets closer to 1 with values 1.25, 1.1, 1.01, and 1.001, the function value f of x gets closer to 3 with values 3.8, 13, 3.310, 3.030, and 3.003. As x approaches 1 from the left, the function value gets closer to 3. As x approaches 1 from the right, the function value also gets closer to 3. We can see that the function value f of x gets closer to 3 from both sides. Therefore, the limit is 3. And we say the limit of the function as x approaches 1 is 3. Let's look at cases where the limit does not exist. Here is the function. F of x equals absolute value of x over x. If we express the given function as a piecewise function, it is as follows. F of x equals negative 1 for x is less than 0, f of x equals 1 for x is greater than 0. When we plot the graph, we can see the following. The left-hand limit as x approaches 0 is negative 1. The right-hand limit as x approaches 0 is positive 1. Since the left-hand limit and right-hand limit are different, the limit does not exist. Let's look at another case. When we plot the graph, we can see the following. As the x approaches 0 from the negative side, the value of f of x diverges to negative infinity. As the x approaches 0 from the positive side, the value of f of x diverges to positive infinity. Since the left-hand limit and right-hand limit are different, the limit does not exist. Now let's look at a case similar to the function we just examined, but slightly different. When we plot the graph, we can see the following. As x approaches 0 from the left, the value of f of x diverges to positive infinity. As x approaches 0 from the right, the value of f of ing also diverges to positive infinity. Although both the left-hand limit and right-hand limit are equal to positive infinity, the function does not converge to any real number L. Therefore, the limit does not exist. See you next time!